There we go. So as everybody's logged in, on Monday, we went over the syllabus. We were also looking to see if we had DB Studio Forge installed. We don't quite need it yet, but we checked that and pinned it to our taskbar. We just tapped DB and seen DB Studio Forge was installed on, should have been installed on most of these machines. So we just right clicked and pinned it to our taskbar. It's a little blue Superman S. Spider-Man. It's a blue Spider-Man S. There we go. Spider-Man's a big movie out right now. So Rick shows up. I'll have to fix. That. Date. Okay. So we're going to week 1. So you do have an assignment to read chapter 1 and do the self-test on page 27 and 28. I don't know if y'all will be, did Lucas just disappear? He did. Must be internet or something. Okay, so make sure I'm recording. Yep, I'm recording. So yeah, it's supposed to be due Friday. We'll talk about the questions and stuff. This first assignment, I know some of y'all may be still waiting on the book to get shipped in or finding it somewhere. So we'll probably just read these questions and you can submit them on Friday for this first one. First week anyway. By next week, you should have your book in and be able to start submitting the assignments beforehand. But if you're able to get the book and get these in, maybe we can discuss some of the questions first off. Let's look at, I'm going to go and bring up the PowerPoint for chapter 1. So it's not really the way I want it to be displayed. Let's see, download. There we go. Open. Yay, chapter 1. Excited, right? Maybe, yes. So database. And I told those that were here on Monday that the book or the SQL language itself doesn't actually define the word database anywhere in it. So that's kind of interesting. What do you think of when you hear the word database? Anybody? You can talk. Place this. Oh, I didn't admit him. Now he's in there twice. So really the basic here, the first bullet up here, the definition of database is just a collection of data. Cool. It doesn't even define how the data is supposed to be stored. Could just be a pile of data somewhere in a folder. It's kind of useless if you got a pile of data. If you had the Lord of the Rings book and you just had every single word just in a jumbled mess, it wouldn't make any sense. So that's sort of what the basic definition of a database is this whole bunch of words, numbers, objects in a big pile. So that's not really good. We move down to one of the more popular database types, a relational database. So we'll be studying in this class. That means the data needs to be collected into some type of organization. In our case, the relational database, you collect data into tables. What does a table look like? That looks like a table, right? You've seen Excel spreadsheets before, I hope, where you have things like last name, first name, birthday, social security number, and then you have rows of data. Like Doe, John, 1/1/1900, he's really old. Social security numbers 1, 2, 3, 4. Awesome. I think that's even before social security numbers were used. Anybody taking political science know when social security numbers were first used? I think in the 30s, I believe. But we're not going to spend time to research that. That was just a quick question. See how cultured y'all are. You're as cultured as I am, so we'll move on. Each of these tables, of course, needs to be collecting data about a specific items. And relational database means you have multiple of these tables and they somehow are related to each other. So maybe somebody's information, first name, last name and stuff. If you're thinking of you as a student, that information is also related to this class, maybe some other classes. So it'll be a table about the different classes, who's the instructor, what's the course description, how many credit hours and stuff. So that'd be stored in a separate collection bucket. And faculty and staff, they'd be stored in an employee type table. So everything's kind of organized instead of just all jumbled up. If you put all the faculty and all the staff and all the students in the same table, it might get confusing on who's supposed to be teaching the class, who's supposed to be paid and who's supposed to be paying. So relational database means you separate things out into tables and you somehow link them together across columns. And a column is, the up and down. So I'm hoping that's not a terribly hard concept to think about or visualize, since I showed a picture of an Excel spreadsheet on the screen. Here we have table, that is something defined in the SQL language. You think of it as a spreadsheet. You have columns inside that table. The key thing about the column, though, is when you're reading through the book, you'll hear it called an attribute. Why is it called an attribute? Well, instead of just column, it's if you have a table for customers going to have certain attributes that you want to store. The DMV wants to store stuff about your height, your eye color. Do they have weight on there? People's weight changes an awful lot, but height and eye color don't change too much. Hair color, maybe, no. Ladies change their hair too much. Men too. We don't like the gray. Like, no, I'm not silver. So it's an attribute about a person or an attribute about an object. So you'll have to think of attribute or column as one and the same. You've heard of a thesaurus, right? Look up words and figure out what synonyms, same words, similar words. So that's what this is, column and attribute. You'll have to get that into your head that those are one and the same. And you'll see attribute used more often probably than column when you're reading through the book. When we come down to row, you've probably never heard of a tuple before. You may have heard of a tulip. Nice flower. but maybe not a tuple. What the heck is that? So now you learn a new word. It's the same thing as a row. It's the collection of information about a record, an entity inside of a table. So a single row has somebody's first name, last name, birthday, height, eye color, stuff like that recorded into it. How are you going to remember tuple? Because you're going to think of tulip. And then you're going, well, what did Mr. Goodman say? And then you're going to start thinking of butterflies. And then you're going to go to YouTube and start looking at how the monarch butterfly migrates, and you're going completely off the subject. And then somehow you'll get to watching a Nazi video on how we beat the Nazis in World War II. So, see, I'm a pro. I know what you're going to do already. But somehow match up row and tuple together. Cool. Any questions? Any comments?
Oh, you know, we talk about potential security number started with max 36.
I said I thought it was in the 30s.
Yeah.
Around the Depression era time. Yep. Cool. So you used Google. Guess what? Google's a humongous database. And you just queried a database and found some data, found the answer really quick. We're going to learn the language, like whenever you type that into the Google search bar and hit submit, what's actually done in the background. We're going to look at some of that. That's the SQL language that'll be executed. So the end users don't see all the nasty stuff in the background. They just see a blank field that they can type something in the submit button. Yay, cool. But you took this class. You didn't take easy stuff. You took what happens behind the scenes. So here comes SQL, also pronounced SQL. Yeah, they just randomly decided to throw in some vowels in there so they could easily pronounce SQL instead of saying SQL. I guess it rolls off the tongue easier. So computer jargon, we go SQL. Have you heard that before? Some people are shaking their heads no, some people are shaking their heads yes. SQL database. If somebody's just randomly talking about a SQL database, they might be talking about Microsoft SQL Server. It's pretty popular. And the other one they might possibly be talking about Oracle. Oracle was a bigger software vendor than Microsoft at one time, but I believe the crown has now shifted either to Amazon, AWS, or Microsoft as being large software. Oracle's still largely up there. But what exactly is SQL? This book, SQL is a language, structured query language. That's where the SQL comes from. S is structured and Q is query. Guess what L is? I already told you, language. Are you bored yet? Are you sleeping? Or are you thinking about butterflies still? Some of you are smiling, thinking, yes, he knows I'm bored already. So yes, SQL is a computer language for accessing data, manipulating of data, manipulation of the database structure, and also database system maintenance. Database system maintenance, actually starting up, shutting down the system, backing up the data. If a company loses their database, do they care? Are they in trouble if they lose their database? Typically, the stuff in their database is their inventory, probably the payroll of how they're paying the employees and tax information, and probably customer information and how to contact them. And if they lose all of that, what are they going to do? Their cash registers and stuff don't work. You ever try to buy something if the power's out at the store now? They're not out much. Power's pretty reliable. They look at you and go, power's out, come back later. When I was little, because I'm ancient and antique, they just had manual cash registers and stuff. And they still wrote things down on paper. So they could function if the power was out. As long as the sun was out and their solar panel calculator could get light, they could calculate up your tax and stuff. So yes, accessing data, that's the query part of it. Manipulating of data. The manipulation of data is what the governor, the Arkansas Center for Data Science, is pushing. All this data is being collected. What are you going to do with it? What's the big thing they're analyzing right now? It's been in the news for the last 2 years. COVID. So they're analyzing, age brackets, who's been vaxxed, who's not been vaxxed, what counties people are getting. So all this stuff's going in this huge database, and the manipulation of data is to be able to query that data and bring it out and build charts and stuff, and something that will show a picture to doctors, to public legislatures and stuff. How can we combat that? Businesses use it all the time to make manipulation of data. You ever watch the ads and stuff that pop up on your screen as something you've been thinking about or talking to somebody about? And it scares you. Like, why is there an ad for this on my Facebook? Why do I go to Google and look up the weather and there's ads on the weather site for the same thing? That's the analytics database data manipulation. So yes, they're wanting these scientists and stuff out there. They need data scientists, not just to shove products down our throat, but solve other problems, endemic diseases, global warming, weather predictions, stuff like that. Manipulation of the database structure, that's changing let's use the big rows, the attributes, the tables themselves, the relations between the tables. So that's manipulation of the database structure. And then of course the database system maintenance, backing it up, scanning for errors, things like that. Okay, next bullet here in the book. SQL defines the words or language typed and what logic those words execute when read by a database management system. So when we're writing the code in our DB Studio Forge and we're connecting to a database, and we're actually typing in letters and brackets and stuff, parentheses and things into the system, those words that we're typing in, that's what's defined in the SQL language. One of the words is select. So that's defined. It has to be spelled select, and it defines what it does. And if you're really curious right now, selects which attributes you want to view. You may not want to view the social security number on the screen. You may just want to view first name, last name, birthday. So select would allow you to type in the attribute names that you want to view. So yes, that's defined by SQL. And that's what we're learning is the SQL language. And then the bullet down here, which will be on probably the first test. Of course, I think all these bullets are probably going to be in the first test. That one, the term database, the actual DATABASE is not anywhere in the SQL language itself. Select, where, between, and, or, a whole bunch of words that are defined in the SQL language, but the actual word database is not. So yes, that's interesting. The author thought it was very interesting. But I will tell you, look at the second bullet. Up here we have database management system. That means a company has written software that when it reads words such as select or where and from and different stuff, it executes it very similar to the way it's defined in the SQL language. And these vendors also decide some of the SQL language is bogus. They don't think that their customers are going to need to use it, so they won't implement it. And they also think that they're smarter than the SQL consortium, and they'll create their own commands that's not in the SQL language that's defined. And one of those commands, it's almost universally defined in Oracle, Microsoft, Postgres, what we're going to use, MySQL, is the actual word database. One of the first things you do when you install a database system is you issue the command create, which is actually in the SQL language, space, and the word database. Even though it's not defined, most vendors actually have it in their database management system that they wrote. So that's why the test question is there, to see if you're paying attention to the actual SQL language. Is database actually there? Yeah, I have to type create database anytime I start a new database and design something. No, it's not defined. Schema and some other things are defined, but not actually the word, quote database here. That's why I have it in quotes up there. Just remember that on the quiz. True or false? Database is defined in the SQL language. It'd be false. Or however, the question is, it could be in reverse. Database is not defined in the SQL language. True or false? In that case, it'd be true. Make sure you pay attention to the question. And I think it's a true or false. I'm pretty sure. Comments, discussion. Is anybody running out of the class crying yet?
Why didn't they define database? Just thought it was like funny or ironic. Do they have an actual reason to not define it?
I guess they decided that that term didn't fit in with querying the data or manipulation of it. They defined something called schema and domains and stuff, but these smart PhD, 160 plus IQ people sitting in a room to determine that it didn't need to be defined. So sometimes smart people don't think logically, maybe, even though they're super logic thinkers. I don't know. They just didn't have it defined. So it was left up to there's not a rule that Microsoft can't implement new things that's not in the SQL language. Typically, vendors like that start implementing something in the SQL language, and other vendors start looking at it and go, well, they didn't patent that. We'll start putting in ours. And it finally becomes kind of like a de facto standard where all the different vendors start implementing a specific way to manipulate data. And then it will get, when they meet to define new versions of the SQL language, we'll start looking at, what's common. Do we need to actually define something and set a standard because they execute it a little bit this way and Oracle does it just slightly this way and Microsoft uses a little bit different math algorithm on this side. So we'll sit down to actually define a word and say, here's how it's supposed to do. Everybody needs to, at some point in time, sync up and execute it this way. If you don't have standards, then it's really hard to learn. Unix, when Unix first started, every single vendor that wrote Unix created their own commands and their own syntax was completely different. So if you're an IT person and you learned one Unix version, you couldn't just easily pick up and go to another company because they probably developed that Unix specifically for like Sears or Target, and Walmart's using a different system. So you can't just change jobs because you have no clue how to use anything on the other systems. I started standardizing, which helped us in IT. We can now demand a little bit higher salary and move around. Before they're like, yeah, you're stuck. You can't find anybody else using this system. So that's what SQL's there, is define standards, make application development easier, and helps out the employees. Okay, normalizing data. You want normal data, you don't want abnormal stuff, right? You don't want to be walking around with 8 fingers on one hand. It's abnormal. You don't want that. Normalize it. What do? They chop those fingers off normally when they're babies. I've known people that you can see a little, they'll show me a scar. Look, I had 6 fingers. It used to be right here. Okay, it's completely different. Normalizing data is not quite like that. That's just to wake you up because you're already going to sleep. I see it. It's database class. Okay, multiple levels exist for normalizing data. It's great. We don't know what normalizing is. There's at least 5 or 6 different rules for normalizing data. However, most people can only really get to the first 3 rules. Most databases are designed only for the first 3 rules because it takes somebody with the extremely high IQ to really get any further than that and follow rule like 4 and 5 and anything beyond that. There's another problem too with that. If you start splitting data up, we'll read through these normal forms, but if you go much further than that, data starts getting too separated out, too granular, to where that the processing power starts increasing. The reason for normalizing data is to reduce duplicate data. Duplicate data is a problem. Why? Has anybody heard about big data? It's like, how much data is on the internet? A lot. And it's going up exponentially. I assume we are probably still in the same curve, but every 2 years, we're doubling the amount of data that's out there. So since the 1950s, when we first created hard drives, the first 5 megabyte hard drive by IBM. Anyway, that's the famous one. They're loading it like 6-ton 5 meg hard drive on the side of a cargo plane with a forklift. And that's all that the plane could carry because the hard drive's that heavy. Since then, every 2 years, we've doubled the amount of data that's been stored in the world. So designing database where you eliminate duplicate data is key. That's what normalizing data is for. So we're going to have some videos to go through this. The first normal form here, tables must have unique identifier for each tuple or row of information. That's not too hard. That doesn't really have much to do about duplicating of data. It just says that each row has to have a unique ID. What would a unique ID be? For you right now, you probably would think of your student ID being a unique identifier. Maybe your social security number is a unique identifier or a barcode. We'll get a little bit more detail. It's not good to use student ID or social security number, things like that as a unique identifier. We'll talk about that later, but for what you're introduced to right now, that's what you can think of, it's going to uniquely identify. Does anybody else have your social security number?
Not that I'm aware of.
If they do, you may have some legal issues for a while. You might not be able to buy a house or a car later on if somebody else has your social security number. So we're hoping it's unique to you. So there's first normal form. The second normal form, this one really gets into stopping the duplication of data. The attributes or columns in the table must be relevant to the unique ID. So a student, you're thinking, what's unique to you? Your last name, first name, middle initial, birthday, address, stuff like that's unique to you. How about database technology class? Is database technology unique to you? Is it an attribute of you? No. It's something you're going to take, but the database class is its own entity. It's this class. You don't have to take it. It doesn't need to be assigned to you. So database technology, the actual words database technology, if we somehow put that in the student table and matched it with your name, everybody in here would have to have database technology attached to their name. So we have what, 9, 10 people? So the word database technology is duplicated 9 or 10 times if it was put into the actual student table. Second normal form says, no, don't do that. That's the name of a class. That's not anything to do with a person. So the class name has nothing to do with the person, so don't put it in that table. Make sure every single column, every single attribute is related to what that table's wanting to record. And you make sure that it's unique and relevant to that ID. Cool. Third normal form. So attributes in the table can only be relevant to the unique ID and cannot be dependent on another attribute. So if you have any type of attribute, make sure it's only dependent on the unique identifier, and it can't also be dependent on something else. So it doesn't need to be related to two different things. That starts to take some sitting down and brain power, lifting weights, running the track. Remember I told you about that on Monday, I think? And you're like, we're IT people. We don't want to go exercise. Yes, third normal form is kind of like that. That's why some people shy away from database class, is the extra analytical thinking and stuff, critical thinking, to get third normal form in play. I have a video that will describe normal form, probably be better for you. It's right here. Normalizing and entity relationship diagrams. I'm going to pause the recording because anybody watching this on YouTube or re-watching this so they can go to sleep tonight, you won't have any trouble falling asleep if you watch, if I post any YouTube videos of this class, like play Mr. Goodman's voice, clunk, 30 seconds, 2 minutes max, you'll be asleep. So I'm going to stop or pause the recording, and you can click and view the video on your own computer. Okay, I'll go back to recording. Lucas says he stayed up too late playing games. So we finished watching normalizing, and we looked at one type of diagram, entity relationship diagram. They probably created that in a Microsoft Office product called Visio. You normally have to purchase it separate. It's got lots of diagramming and modeling tools for database and other diagramming that managers and stuff would use, non-related to IT stuff. It's really cool. We're not going to use Visio because I don't see that it's a part of our Office 365 offering. We're going to use a free product later on, open source, originally written for Unix, Linux. It looks like, I know you can get it for Windows, and I think you can get it for Mac too, because Mac OS X is just BSD Unix. So it shouldn't be too hard to port stuff from Linux to Mac. So now what do we want to do for the rest of the day? Let's see. I don't think I finished the PowerPoint. I'm pretty sure I didn't finish the PowerPoint. So their third normal form that she had listed, she had it a little bit different than our book describes. It says you have to eliminate calculated fields, but the better is the attributes in the table can only be relevant to the unique ID and cannot be dependent on another attribute. That's a better definition of normal form. So you feel like you have slightly better grasp of what normalizing data, what it entails. Entails a lot of brainstorming and a lot of drawing circles and boxes and lines and underlining things, understanding what a primary and foreign key actually means. And where you get to creating tables and stuff and doing some of these diagrams so we can build out our own little sample database, you should start understanding it a little bit more. There is a training database that comes with the book, and also a generic training database that's just out there called the Chinook database. It's a music company sample database. So I figure most people know a little bit about music, songs, artists, and things. So we'll deploy that possibly as early as Friday. If not Friday, we'll deploy that next week and start looking at a fully developed database. This already has data in it. We also need to start thinking about a database that we'd want to create for the class, because you can't just, I mean, yeah, we can look at a pre-existing database, but it makes a little more sense, especially in the chapters where we're doing the database structure. I mean, we're manipulating the tables and attributes. We actually just have one for ourselves that we're creating in class, and then we use a diagramming tool, kind of like she showed, to come up with, you know, what are we going to store database on? So you might, that's kind of your homework project is, what would we want to do a database over? I don't want to do a database over like Walmart because that's just enormous. Thinking of something like a hobby. Something that wouldn't have a whole lot of tables that we'd need to create. We've done stuff before. We took a intake form for a safe haven house and built a database out of it. Maybe not a complete one, but we started the structure and come up with some attributes and stuff and different tables we'd need. We've done an ammo database before for a shooting hobby. Although we can't get ammo now, so. We've done a database over backyard chicken farm. Baseball card collections, maybe. Pokemon card collections. You know, some of you guys are like, ooh, let's do that. What somebody warned last time, don't do the one over a chicken farm, but I'm actually starting up a chicken farm. Chickens, a chicken project. I already built a coop over the holiday break in a pen and got the doors and latches. I went somewhere and found some parents, got eggs from the Perrys. If you went to BB Public School, you might know the Perrys. Anybody go to BB Public School? You did? So the Perrys, Jackie Perry is head of food services for the whole entire district. I don't know if you've heard of, probably didn't. You just knew the lunch ladies that gave you the food and the rolls and stuff, like food. Yes, IT. I was like, you might know Preston Perry because he's all over the place. Me and him started working together at the same time. And he stayed on and I came over here. So they're the ones, they have the chickens, collected some eggs, 24 eggs. And they are now in the incubator going, so. I don't know that our chicken farm database turned out really great last time, but we don't have to have a finished product at the end of the class. We just need some ideas to start, you know, what type of tables and attributes, build a small database. It doesn't have to be fully functional at the end of the class, but just as long as we have some things going on. So that's kind of a project for you to think of. What would we want to do? We can do something we've done in the past. We do something new. Everybody in here is different, so I don't think there's a single subject that we'd hit on that everybody would love. Maybe, I don't know. Game console inventory and game inventory or something that might hit on a lot of people. I don't know. We'll vote on that at a later time, but that's something to start thinking of for this class. I mean, I don't have an assignment that says, hey, you come up with an idea, I'll give you so many points. It's going to help us learn the stuff in the book, the things we go through. So I got your brain's cogwheels going. What do I like to do? Nothing. Sit at home, stare at the wall. Okay. Maybe a database on the number of spam calls and spam messages we get. Yeah, they're so random, that's not cool either. It says they found 3 viruses on my phone, click this link. Yeah. No, delete. And also get, you paid your AT&T bill. Here's a freebie. Anybody getting those?
I've gotten.
I'm not the only one that's got those. I'm like, I don't have AT&T. Oh. Get the phone calls. Your DirecTV service will give you 50% off. I don't have DirecTV. Okay, it's not really part of the class, but that was probably not a good thought to use that as a database. I now click I silence any calls that aren't in my contacts. Text still bleep through, but all the spam callers no longer ring. I just get notifications. This random number was silenced. Like, cool, they didn't leave a message. They didn't want to talk to me. So much nicer. Okay, let's look at this slide number 5. Try to get back a little more on subject. Types of SQL statements. The type of SQL statements that we'll be getting into, there are 3 different types. Data definition language, DDLs. They're used to design the database structure itself. So in the SQL language, there's defined certain things like create is one of the words, table is another word. So you can create a table. So anything that's manipulating the table, you can also, some things like var character or integer or float, that can define what type of data can be stored in an attribute or a column. So those are data definition languages, meaning the structure, not anything to do with the data, not about somebody's last name, first name, birthday, nothing like that. But the actual, like the field, what are you going to name the last name field? Are you going to call it last? Or are you going to call like L name? Or are you going to spell it all the way out? Last underscore name? What are you going to do? And then what type of data is it? Or is it going to be variable length? How long? How long is somebody's last name? That's got to be all thought about. And you got to think about people from foreign countries and how long their names can be. I went to school with somebody that was from India. We called him Lak, L-A-K, because that was 3 letters in his 28 character name. He's like, I realized that if you're going to communicate me via chat, because that's how we communicated, was via chat, but you're not going to type out my entire name. Space. How are you doing today? Like, no. So just L-A-K is good enough. Okay. So yeah, data definition language is designing the database from scratch. Those type of languages are used up front when you're creating the database. Once the database is actually defined, the data definition language commands are used sparingly as you're upgrading and maybe expanding and improving your database, versions that are coming out with your product. You might use data definition language, but that's all up front. Then we move to data control language. This is used for administration, creating user accounts, setting up permissions and stuff within the database. Who has access to insert data? Who has access to read data? From what tables? What groups of people are in the system? What's their passwords and stuff, user accounts? So that's data control language. You can also do things controlling the database itself, like backing it up, starting and stopping it. So data control language is controlling the database, controlling access. That's normally a job all by itself. Your database administrator. So they're going to go in, deal with permissions, deal with patching the database. It's software. So it's going to have patches. Don't you install patches in your computer, or Windows does it for you? Well, the database is normally not so automated because they're afraid of what if we install a patch and it breaks everything. You should probably have a database admin go in there and engineer, back the database up. Look, do I need to shut it down? What do I need to do to install this patch, get that installed and restart the database, check, make sure everything come back online and communicating with the front end web applications and stuff. So those are data control language. Then we move down to the language that's probably used most often in SQL. That's data manipulation language. You're dealing with the data. So after everything's all set, user accounts are created, permissions are set, tables are created, relations are made between the tables. Then you start putting data into the database and retrieving stuff out of the database. That's all data manipulation language, DML. And I hope you can see where that's probably the most common thing that you would be doing. Like I said, just think of point of sale systems, any store that's ordering stuff or selling stuff, all that's going into the database using data manipulation language. You enrolling into classes. You checking the portal to see what your schedule is, to figure out, forgot which class I'm supposed to go to today. That's all data manipulation language stuff going on in the background. Questions, comments? There's only 3 things we have to learn. Cool. It's a lot of stuff in those 3 things though. But it does sound easy, right? Just 3 things. The video, she talked about relationships between tables. And she showed a one-to-many relationship, or many-to-many. Pretty common. One-to-one, 2 tables are required, which means I don't know that there's a lot of one-to-ones where you have exactly 1 row matches with only exactly 1 row in another table. And there's not ever going to be any other difference. So if that's the case, if this 1 row only matches to 1 row of data in the other table, and it's never going to match to anything else, wouldn't it be easier just to move that into the other table? Sometimes when you go through the different normal forms, stuff gets split out like that. And you'll have one-to-one relationships. I mean, there's scenarios where you want that to happen, but sometimes it's not a required one-to-one. Sometimes it's 1 to maybe null. That can happen sometimes. And then 1 to many, that happens a lot. 1 person can be assigned many things. I don't know exact scenario right off the top of my head, but many to manys are probably more common that I can see. And you can't just directly link 2 tables together with a many to many relationship. The YouTube video we just watched, she created 3 tables. She had a table for the customer, she created a table for the tours, and she created a 3rd table for bookings, which linked the customer to the particular booking. And that middle table, that linking table, a 3rd table, normally contains only 2 columns. And that's what she showed in the YouTube video. It only contained the customer ID and the ID of the tour. That's how that you can look in that table and you can see customer ID, okay? I can go look at the customer table and look up 001 and I can pull the name, address, phone number, email address, whatever for the customer. Then I can look in the other column right beside it. It has bookings. I can go over and see, oh, it's September, the advanced tour. And then you can print that out on the screen. But that requires 3 tables to be made. It's quite common to see that scenario. There's a test question on this many-to-many too. I can't remember if it's true or false, but it's probably an easy true and false one. You can link a many-to-many relationship together with 2 tables. No, it's false. It requires a minimum of 3. Cool. We get to the end of chapter 1. We have a couple of minutes left here in chapter 1. I don't really want to play with software yet. But while it's fresh on your mind, you might want to open up Notepad or something, probably Notepad. You might want to do chapter 1 homework. And what I'm looking for in answering these, I have the questions in front of me. You know, K through 12, they may have like, write the question and answer out. That's duplicate data. This is database class. We're supposed to normalize stuff. Let's not duplicate things. So I'm not asking for you to write the question up. But number 1 up here is asking, what is a database? So I know a lot of you don't have your book, but that's question number 1. What is a database? What would you put for that? It's an open-ended question. It's not multiple choice.
Collection of data.
Collection of data. I would even accept data as an answer. The one cool thing, we're already helping answer these. So number 2, which of the following objects make up a relation? Which of the following objects make up a relation? And we have A, data type, B, tuples, C, attributes, and D, forms. This one, I don't want you to just put A, B, or C. I want you to go ahead and go like B, tuples, or whatever, because you may have a different printing of the book. And I've seen I think I've seen one printing where they've shuffled the order. So go ahead and put the word or words. Some of these have multiples. So forms. What do you think of when you hear the word forms? A web page with a bunch of fields that type out stuff in, right? That probably is not anything to do with the relation. What is a relation? Which following objects make up a relation? That means one table, how is it linked to another table? So think of that little diagram we had before. What was she linking together? How did she link the 2 tables together? She linked them on columns. She created a 3rd table and created a column called customer ID, which matched the customer ID in the customer table. And then tour ID, was it? We'll just say she made tour ID and she matched it to the other table's tour ID. Those are columns or attributes. So I would want C, attributes, as an answer. A lot of these multiple choice have multiple answers. It doesn't tell you that there's multiple answers. But I know forms is not an answer. I know that's an answer. Let's look up here, data type. I don't remember hearing data type in the presentation too much, although I did say integer, var character, stuff like that. That's what data type is. That doesn't have anything to do with the relation between two tables. What's a tuple? What's tuples? It's rows. You don't link two tables together on rows, only on columns. So that is not an answer. So after we've eliminated all the wrong answers, we know this multiple choice question only has one C attributes. The question, which of the following objects make up a relation?
Can you look at my screen real quick?
Maybe. Have you broken something?
Well, I'm looking at the F build, there's got, says a relation is a set of columns and rows.
Let's see. Yeah, but
Incorrect, or am I getting something wrong?
a relation is a set of columns and rows collected in a table-like structure, represents a single entity made up of relational data. Let me look at the question. Which of the following objects make up a relation? Don't like their little paragraph there. It's a good catch, though. Let me double check what the author said. The answer was. Is that on page 6?
Yep.
So grab the page number. What they are describing, the relation is a set of columns and rows collected in a table-like structure that represents a single entity made up of related data. That's really more of a definition for a record. An attribute is a unit fact that describes or characterizes an entity in some way. Yeah, it's just attributes. They're yeah, it's just attributes when you're linking two tables. That's the gist of what that question's wanting is attributes. I wouldn't have counted wrong if you put both of those up there because it is kind of describes that on page 6, but the relation between two tables is done across the attribute or done across two columns. Okay, let's I guess we can do one more. And then I'll let you out a little bit early. This one is fill in the blank. We have a blank up here. Is a, we don't have to type type it all out, but there's a set of data whose values make up an instance of each attribute. I guess I should hit enter somewhere. Defined for that relation. That's kind of like, what? Can you think what they're asking? This is also on page 6. If you do have your book. A set of data whose values make up an instance. One single thing. An instance is meaning one thing of each attribute. What are attributes? Attributes are columns. Each attribute means there's more than one column. An instance means one thing. So you have values, meaning you have one row, one instance of a bunch of columns. So we're talking about row. What's another word for row? Tuple. So what they're looking for as the answer is row tuple or tuple. Specifically, they want tuple. As the answer. But you could put row or tuple because they're one and the same. Yep, it's definitely a new mindset. Reading questions in a database type class. It's a little bit different. Some of you are other, like some of you went through hardware, software, Cisco. Database can be a little unique answering questions. And any type of coding languages I've taken in the past, I'm typically always 1 or 2 weeks behind where I would understand the questions, which is okay. Sometimes you may have to wait till after chapter 3, come back and reread these and go, oh, that makes a lot more sense now. You'll feel that, and that's okay. If you don't feel that, then you probably had some type of database or your IQ is just already like, yeah, this makes sense. You may just have a natural knack for it. That happens, but most of you are probably going to be, I don't understand these questions fully until you, like I said, it definitely help you to come back to these questions and reread them when we get done with the chapter 2. Go back. So number 3, you could have preferably tuple as the answer. And since you're copying off of me, cheating, yes, you can put tuple up there. So what I would do, I would save this somewhere like chapter 1. And what I would do if I was you, I would go to your email, use your waffle and go to your OneDrive, and I'd create a folder for this class. So once you were in OneDrive, you create a new folder. put database technology or however you want to. Goodman's crappy class, or whatever you want to name the folder. And then once you got that folder created, just in case these computers get wiped or something, or you want to work on this same file at home and you've already forgot what the answers to 1, 2, and 3 were, you could just drag your homework, chapter 1, from your documents folder up into your OneDrive. I'm wondering if you can, I guess I should go ahead and do that. Can I edit? Chicken farm. Not chicken farm. Chapter 1. Where'd my chapter 1 go? There it is. Chapter 1. Copy to. It lets you edit Word documents. Maybe you should save it as a Word document. Now you can open it in text editor. You can edit it right here. Once you click on the file. Use technology. It's great. Once you're completed with it and you're ready to submit it to Canvas, you can download it to your computer, log into Canvas, then drag and drop it into Canvas and submit. Neat. So is that book on Amazon that you're looking inside and you can see the questions in all of chapter 1? Cool. See if you can get most of those. There's 15. See if you can come up with Friday. In the beginning of class Friday, I want to go around the class. We'll start up here with Robert probably. And he'll answer number 4 for us. We'll go along to Elijah. We'll have number 5 for you. We'll just kind of go around. See what you come up with. Sound good? Like, no one answer. Okay, I'm going to stop recording.